Welcome to this explainer. Today we're taking on a beast of a problem, WASSCE Mathematics 2025 Question 4. Now, if seeing a fraction completely shoved inside a logarithm makes you want to run for the hills, hey, you're definitely not alone. But don't worry, we're going to break this down gently, step by step, until it makes absolute, perfect sense. Oh, and by the way, if you're looking to prepare smarter for your upcoming exams, you'll for sure want to check out QandA at QandAHelp.com. They're an amazing study tool for WASSCE, NECO, and a bunch of other exams. But for now, let's just jump right into the math.
Okay, let's establish exactly what we're up against here. The equation we're starting with is 2 times log base x of, well, this whole messy expression, 1 minus the square root of x, all divided by the square root of x, and the whole thing equals 0. Our mission? Find the hidden value of x from the options 1/2, 1/4, 1, or 0. At first glance, that fraction inside the logarithm is frankly a total nightmare. But, in mathematics, the absolute best way to handle a massive problem is to just start chipping away at the edges.
So let's actually do that. First things first, we've got that rogue number 2 sitting right at the front, just multiplying our logarithm. We really don't want it there. We want the log totally isolated to see what it's actually doing. So if we just divide the left side by 2, it cancels out. And what happens on the right side? Well, 0 divided by 2 is still just 0. Just like that, our equation is simply log base x of our messy fraction equals 0. The outermost layer of the puzzle, gone. Now, to unlock the rest of this problem, we need to use a fundamental shortcut, what we call the logarithm zero rule. It's super simple, but absolutely crucial. The rule states that if log base a of any expression equals 0, then that inside expression must literally be exactly 1. Why? Well, a logarithm is really just a question about exponents. It's asking, what power do I raise the base to get the inside number? Since the power here is 0, and literally any valid base raised to the power of 0 equals 1, the inside has to be 1.
Think of it like this, and this is my favorite way to visualize it. Imagine a logarithm as a literal growth machine. You put something in, pull the lever, and it multiplies your stuff by a certain rate. The base of the log is the machine itself, right? And the number of equals is how many times you pull the lever. Now, if our machine runs 0 times, well, nothing happens. There is absolutely 0 growth. You are left with exactly the one single unit you started with. It completely doesn't matter what the machine's growth rate was supposed to be. If you never turn it on, your value stays exactly at 1.
Applying that growth machine logic directly to our problem is a total game changer. Because our equation equals 0, our growth machine ran 0 times. So that entire chaotic expression sitting inside those parentheses, the 1 minus root x over root x, must simply equal 1. And boom, the logarithm has completely vanished. We've elegantly transformed what looked like a horrible log problem into standard everyday algebra. Now we're just doing some basic housekeeping. Let's flatten this whole thing out by multiplying both sides by the square root of x, which gets rid of our denominator. Then we just group our matching terms together. If we move that negative root x across the equal sign, it turns positive. Add them up, and suddenly we're looking at a much friendlier, much cleaner equation. 1 equals 2 times the square root of x.
We are seriously in the home stretch now. With a quick division by 2, we get the square root of x all by itself, equaling 1/2. But remember, we don't want the square root of x, we want plain old x. So how do we undo a square root? We literally just square the whole thing. Squaring the left gives us our target x, and squaring the right means simply multiplying 1/2 by 1/2. And there we have it. Our target value for x is perfectly isolated as 1/4. We successfully navigated all the way from that complex logarithm down to a single clean fraction. But hey, to be absolutely bulletproof, let's just quickly plug that 1/4 right back into the original equation to prove the math is rock solid. If x is 1/4, then the square root of x is 1/2. Now think about that inner fraction. We plug in 1/2, 1 minus 1/2 leaves us with 1/2 on the top, we divide that by 1/2 on the bottom, and obviously any number divided by itself is 1. Finally, we apply the log, and the log of 1, as we know from our growth machine analogy, is always 0. The math checks out perfectly.
Time for a quick victory lap. Let's review the 6 completely manageable steps we used to conquer that beast. First, we got rid of the 2 by dividing. Second, we brought in the 0 log rule, remembering our trusty growth machine. Third, because of that rule, we set the inner fraction to 1. Fourth, we multiplied to flatten out the fraction. Fifth, we collected our square root terms together. And finally, we squared both sides to reveal our answer of 1/4. When you look at it like this, it's just a logical, easy-to-follow sequence.
All right, let's see if this actually stuck. Quick quiz for you to test your memory.
If log base 2 of y equals 0, what must y be? Think back to the core concept we established earlier. The base is 2, but the whole thing equals 0.
If you said 1, you hit the nail on the head. It proves you've totally mastered the growth machine analogy. It literally doesn't matter if the base is x, or 2, or 10,000. If the log equals 0, the inside value is always 1.
Okay, one more. Just testing those foundational algebra reflexes. If the square root of x equals 3, how do we find x? Think about the very last operation we did in our main problem.
You got it. We simply square both sides to get 9. The square root and the square just cancel each other out, leaving x, and 3 squared is 9. Honestly, getting super comfortable with these basic, reversible maneuvers is the absolute secret to flying through exam questions.
So, wrapping it all up, our final WASSCE 2025 question 4 answer is option B, 1/4. By systematically breaking it down and using that growth machine analogy, an impossible-looking problem became a total breeze. Make sure you head over to QandAHelp.com to keep practicing and totally conquer your next exam. But before you go, ponder this. If logarithms are essentially the math of growth machines, how do you think they're used to measure things in the real world, like the chaotic growth of an earthquake or the compounding interest sitting right now in a bank account? Keep learning, keep practicing, and I'll catch you in the next explainer.